Welcome to my session on building a multiplayer version of Space Invaders. Now, I know that this was not really the topic that was listed on the schedule of the conference, but I didn't know I could build a game in less than 2 weeks, but here it is. Things worked out, so this is what I'm going to talk about. I'm Srushtika Neelakantam. I tried to, overdo my slides, make them super retro. As you can see, I pixelated my picture as well using an online tool. Didn't turn out quite as expected. Looks like a bunch of freckles on my face. Anyway, I'm a developer advocate for a company called Ably Realtime. Ably offers a real-time messaging infrastructure as a service that you can use in your applications to incorporate live or real-time sort of functionality. In my spare time, I volunteer with the Mozilla Foundation. Specifically, I'm involved with the Tech Speakers program. They promote web literacy through a bunch of volunteers like myself and so many others across the world. The last one is actually a book I wrote back in uni. Don't buy it, it's out of date. But it talks about web-based virtual reality, specifically WebVR and A-Frame. Those are two really awesome web frameworks for building virtual reality on the web. They have awesome documentation, which is up to date. Go check that out if you're interested in that. But you can reach out to me on the email or on Twitter for any questions about anything that are in this talk or anywhere else, and I'll be happy to answer. If you like anything, make sure to tweet and at me so I can see that as well. Now, before we get into understanding any of the cool stuff that's behind the hood of any cool games, let's actually play a game together live in this session. A couple of things before we get started. This demo is capped at 10 people, so fastest fingers first. If you're among the first 10 people to join, you'll be able to play the game. Just to make sure my system doesn't break because it's not hosted on a cloud function or something like that. It's just on my system. You can open the link in a computer browser. I haven't really, added any inputs for the phone yet. But for your best experience, maximize the window, set the magnification to 100 or less, and you're good to go. So the key thing to note is that this video stream is running about 15 to 30 seconds behind what's actually happening in the real world. So what I'll do is I'll join the game. That's the link that you need to join. I'll do things as slowly as possible, try to stay alive. By the time everyone actually joins. So let's actually see how it goes. The URL is go.ably.io/play-space. Fastest fingers first. I'm going to open it up in my browser. For everyone else who are not among the first 10 people, please look at my screen to actually see what's happening. To kill some more time, I'm going to give myself a weird nickname, HalfStack Srushtika. And that's, I'm actually late and people are already there. So as you can see, you can scroll, you can use your arrow keys to move around. The good thing about this is no one knows who's where. So you just have to click and see what's happening and make sure you're not killed. So there's one person that's managing to get to the end. And that's Kevin. And Tom's the first runner-up. So yay. The game actually ended sooner than expected because I didn't manage to win most of the times that I was testing. Anyway, so that's the game. Let me now close this, get back to the presentation, and actually tell you what is happening in the game, how it's built, the different design patterns that went behind it, and everything that you need to know to build a game like that for yourself. So among all the different things that are moving in a game, quite literally, there are three core components. The first one is, of course, the assets. Now, you saw different avatars moving around. These assets could be something you draw on the game canvas or, import as an image or a sprite sheet or even as audio. Actually, that reminds me, the game actually had audio. When you shot the bullets, they had retro-like gaming. But unfortunately, Glitch had some issues and I had to drop them for this demo. But we can still add them on the main project that I have on GitHub that you can check out later. But assets are the crucial part. But after you have the assets, the second core component of a game is the physics. Once you have the assets, the way these assets or objects interact with each other and with different objects in the game is defined by physics. It is possible that you write all of the physics, mathematical components from scratch. But why would you do that? Because there are so many amazing, physics engines available to be used out there, and it's basically a faff to write all of those mathematical functions from scratch. So that's what we look at for this game as well. But the third component, which is especially useful for real-time multiplayer games, is networking. Of course, you saw that the game was multiplayer and it showed the same context for everyone on my screen as well as the 10 people that actually logged in into the game. If it were so that on my screen I saw the ship on the left and someone saw the ship on the right, it wouldn't really work because it has to be synchronized all the time. So networking is one of the most crucial parts in a multiplayer games. So let's actually break these down one by one and understand them a bit deeper. For assets and physics, in this game, I use something called Phaser. It's a really cool, library which renders canvases and WebGL on browsers for all your games. And the cool thing about that is it does not only manage your assets and including audio, sprite sheets, and whatnot, but also it comes with an inbuilt physics engine, which means you get two for the price of one. So one more thing to note here is that I've used Phaser 3. The reason I specifically mentioned that is because Phaser 2 and 3 are entirely different. The syntax doesn't even look the same. They're almost like two different libraries. So make sure you know which one you're using and you're referring to resources corresponding to that version. Let's actually get into a bit more deeper into how Phaser works. Everything starts with a configuration object. This is where you'll specify the size of the canvas that you want your game to be rendered in, things like styling aspects, the background color, etc., and also the scenes. Now, scenes are different, worlds that in which your game is running. For a game like Mario, your avatar is transported from one world to a different world depending on your game logic. The game that we just saw has a single screen, so a single game. But all of those scenes that you have in your game, according to your game logic, need to be listed in this game config. Now, this game config, so the scene itself is a class that extends phaser.scene. And in each of these classes, there are three default methods that come with it. The first one is preload. What you do here is load all the assets that you might require at some point in the game. Basically, tell Phaser, hey, just keep this ready and I'm going to use it at some point. I'll tell you when. And, just don't make any delay when I actually have to use it. So you specify those assets there. Next is the create function. The create method is executed once for every scene when it is rendered. So you can use that to initialize all your variables in that method and also create any initial avatars that you want as soon as the game has started. The last one, the third one, is the most important one, which is an update function. This function runs in a loop all the time for as long as the game is running, and this is the one that's responsible to move the objects around constantly as per your game logic. Now, this just basically keeps running and says, right, the avatar needs to be on the left, avatar needs to be on the right, so I need to move it, and that constantly keeps happening. So it appears like a video, but it's actually not. It's just changing the position of all of these assets continuously, giving us an illusion of it being some sort of a video type game. So now that we have this information, let's get into the code and have a look at what scene I have. So I have a script and a server. I'll explain why I have these two things in a bit. But what's important now is there's a config object. As I said, there's a width and a height and some other aspects. There's a game scene as well. Now, game scene is the class name that I have. And I have the preload method, which loads a bunch of sprite sheets and other types of assets. There's a create method, which initializes a lot of variables and adds different avatars according to the game logic. We'll get into that also in a bit. And then a bunch of different methods that do different functions in the game. Then there's the update method. In this is where, as you can see, the ship body and the players, all of the avatars of the players are being constantly updated as per the data that I'm getting from the server. Now, why I'm getting this data from the server, etc., we'll understand in the next component of the game, which is networking. But one thing before that is after the configuration and the game scene are specified, you start a new game by saying new phaser.game with that particular configuration. Right. So let's now get into the next component, which is networking, which is a very crucial aspect here. Now, networking can be done in a lot of different ways, right? We can have all of these players just talking, communicating with each other, saying, hey, my position is now this. Hey, my position is now this. So just, update my positions, my avatar's position in your screen with the data that I'm sending. But A, it's incredibly confusing. B, it arises n squared problem because everyone is sending messages to everyone else. So it is super difficult to scale this kind of a architecture. And C, all of these players could be lying. You have no way to find out if one of the players has actually hacked into the game and has made themselves immortal, and basically they never die. So what we need instead is, for most of the games which are multiplayer, is a server client or architecture. This is the same kind of thing that you see for general websites or databases and things like that. But what this game server does is it stores the single source of truth all the time, the context of the game, and constantly publishes this context to all of the players continuously at high frequency. In the case of my game, it is publishing a new update every 100 milliseconds, which is 10 messages per second. So at such high frequency for all the players, it actually seems like it's not delayed at all, and all of the game looks like a video instead of something being added or discrete, plugged from a single point and dropped in a different point. It just looks like a smooth transition. Um, this brings us to the concept of communication between the server and the players as well. Now, traditionally, how we'll expect them to, not them, any two entities on the internet to communicate is by following the basic protocol of hypertext transfer protocol, where you have the client sending a request, server returning a response back. But in our game, as I mentioned, it is publishing messages at every 100 milliseconds. So at such high frequency, if you're just repeatedly performing the request and response cycles, all that it would do is add up to the lag, and we can't afford to have any such lag. What we require instead is some sort of a connection that's opened and it stays open, and something that allows communication in both directions simultaneously, because the client is also publishing some data, as we'll see in just a bit. So we need something like WebSockets, where there's an initial HTTP handshake, and if both of the parties, comply with that protocol, a bidirectional full duplex persistent connections opens up, and there's bidirectional data transfer happening all the time. And this connection stays open as long as the game is running, which is exactly what we need. If you're using some sort of IoT devices like controllers and things like that, you might consider MQTT, which is somewhat similar to WebSockets, but it is very friendly for battery bandwidth, less bandwidth devices such as the MQTT sensors and such. So even for WebSockets, like the physics rendering engine that we saw before, it is possible to write a WebSocket server from scratch. But why would you do that? Because there are so many different libraries available already for you to use in any of the platforms that you're working with. Some of the open source options are these, and one thing that you might recognize that's super popular is socket.io. And even with the phase 3 community, socket.io keeps getting mentioned all the time. A lot of people are building a bunch of different things, very cool stuff with socket.io. But the problem is, when you're using open source options, it doesn't really help you scale if you want this game to be really production level, or if you want a lot of different people playing this in real time in a multiplayer way, because so many messages are being transferred from so many different places that it just gets out of the hands of a open source library. And also you may need some add-on features like message ordering, or accepting different platforms for user input, such as IOTT that I just mentioned, etc. So in such a case, you would want to use something which is more a sort of a distributed network that allows you to share messages in a fast fashion. So in this case, I'm using Ably's real-time infrastructure. The way it works is, in the server client architecture that we saw before, Ably sits in the middle. So all of the players would now be publishing data to Ably, which will in turn publish that data to the game server. And the server would publish its 100 millisecond game tick to Ably, which will in turn publish that to all of the players. To understand this more closely, the way Ably works is, under the hood, it implements WebSocket, so it gives you a bidirectional flow of messages, fully duplex. And the connection is kept open. But on the surface, what it implements is a publish subscribe messaging pattern. What happens in this pattern is, all of the participants that are participating in this app are either publishers or subscribers or both. If you see in this scenario, there is a truck, publishing some updates on a channel, and it is a publisher. Now, the customer desktop and the customer mobile are consuming that data, hence they're consumers. The app server, on the other hand, is publishing something but also consuming something else. So it plays the role of both. Another thing that you might observe here is that there are different things called channels. So channels are a way in which you break down the data that you have in your app into logical units of what that data corresponds to. For instance, all the location data would go to location channel, and only the parties that would be interested in that would go in that channel. Similarly, for our game, there are different channels, two common channels, and one single channel for every client that gets added. So the first one is the game room channel. I'm using this game room channel to track any player who has entered the game, and also for the server to send this 100 millisecond game tick with the latest context of the game to all of the players. The second one that is also common to all the participants is the death notifications channel. What I'm doing here now is the client is actually declaring itself dead when the avatar collides with a bullet. But generally you do this logic on the server side as well, but because it was a simple demo, I thought it would be easier to do that way. So what's happening here is the server, a client tells the server, hey, my avatar got hit by a bullet and I need to be dead. And the server in turn sends another message as a different event on the same channel, letting all of the clients know that that particular client is dead. Now, there's also another, set of channels, which is a new channel for every client where their user input is being published. And that's a publish-only channel for clients because they're not actually subscribing to anything there. But the server is consuming that and, updating the context of the game as the users are pressing the left and right arrow keys. One really interesting thing to note here is that as you press the left and right keys, what you might think is that is what's causing the avatars to move left and right. But no, that's not what's happening. It's really important to, definitely make sure that the context of the game is synchronized across all the players. So what's happening instead is when you press the keys, a message is being sent to the server, which in turn is fanning out that message as a single source of truth to all the clients, including yourself. Only after you receive that message are you playing that the explosion animation and declaring the person dead. But you don't really make that out because all of this communication behind the hood is happening so fast that it doesn't really matter. It just feels like it's an action. The action of pressing the arrow keys is what's causing the explosion to happen. That's pretty much how most of the real-time multiplayer games work. But to understand this gaming architecture a bit better, basically, if you imagine a server and the first player and the second player, as soon as the first player joins, the player says on the game room channel to the server, "Hey, I've joined the game." And then the server, because it is subscribed to the game room channel, will listen to this, and as soon as the first player has joined, it will start publishing the game tick at 100 milliseconds on game room. Anyone who subscribed to game room will continuously start receiving this game tick. For now, we only have the player subscribing to this game room tick, which for now is only the player 1. Next, the player 2 comes and joins, declares himself or herself as active on the same game room channel. Now, because this player 2 is already subscribed to game room and something is already being published there, it will already start receiving the game tick and will display the information or the avatars according to the data that's coming through. There's the death notifications channel that I mentioned. The death notifications is used for the players saying, "Hey, I'm dead." It takes it and then basically says, "Hey, this player is dead. Perform an explosion animation on this player at this particular location," and we're done. Now, as I said, there's a new channel per player, player 1, player 2, where they're publishing only their inputs from the keyboard, and the server is subscribing only to those channels and changing its local context, which it will later publish in the game tick continuously. That's already going on. Now that we have a bit of understanding of this, let me actually walk you through the code very quickly. As I was saying, this is the reason why we have we have a front end script and a server.js. So in the front end script, what's happening is I've authenticated with Ably using token authentication. After which I'm attaching to the game room channel that I was mentioning and the dead player channel. And after my connection is established, the server, because I authenticated using a token auth, I can have a unique client ID returned from the server. When that's returned, I'm using that to dynamically name my client specific channel for this particular client. So these three are the only channels that this particular client will be attaching to. After that, when the game starts, we've preloaded all the things. When I in the create method, basically I've subscribed to the game state, which, if you remember, is being published at the rate of 100 milliseconds. So if it's the first player that's joined, if the game has not yet started, then I need to add the ship body at a particular location that the server tells me to, and I also need to add all of the players according to what the server says there are, because the game has already started. There may also be players that were already existing before, so I have a method to add those players as well. The way all of this works is you basically subscribe on the channel to a particular event, and then you get this callback called every time you have an update on that channel. And according to that, I'm updating the score of the person as well, which I'm not only showing on the top, but also using it to declare the people on the leaderboard at the end of the game. So same way, I'm also subscribing to player join on game room, player leave on game room, etc., and also game over, because I thought this game is going to go on forever, and people might actually cheat by trying to refresh the browser. That didn't happen, so everyone's really good in the conference. But I thought I'll basically end the game in 2 minutes, even if people are playing or new people are joining, etc. Otherwise, if someone finishes as well, game over is called as well with the details of the winner, and that will be used to display the leaderboard as well. um, Something else that's interesting is in the update method. What I'm doing essentially is, the way I've stored all of the players and the ship and all of the context avatars is by using associative arrays. And the key of these arrays is, for each player, it will be their client ID, and the object will be the format which I have here. They'll have an ID, an X position, a Y position, a type, which will be randomly assigned from the server, a color, which will be randomly assigned from the server as well, and the score, which will keep getting updated by the server as they're coming down vertically. So that's basically what I'm checking in my update method here, checking all the players by the ID and checking if their X position that's sent from the server is updated. If yes, then I'm finding out the avatar associated with that ID, which is stored in a separate array within the game scene class, and updating the X position accordingly, according to the latest data that's sent from the server. Because this update loop is running all the time, and the server tick is being sent all the time, it just all of the context is latest. So what's being displayed is the latest information, and everyone is synchronized as well. Same thing for the bullets. Every time the server says shoot a bullet at this point, it basically takes the location of the ship at that point and starts a bullet sprite, and it just keeps going there. And the way things are causing an explosion is where something that I can't find. So I'm going to search it real quick. Right. So there's an overlap method where I'm adding an overlap for my avatar only, but all of the bullets that come through before they get destroyed after they reach the top position. And when this overlap happens, I just call a different method. And in this different method is where I basically let the server know that, hey, I got killed in dead notification. Now, the way this works is dead notification is the method I'm using to let the server know that I'm killed. But there's another one, as I was mentioning before, which is dead note fan out, which I subscribe to, receive from the server, and only after which I'm saying, hey, by the way, you're dead. So yeah, you're dead. On the server side, it's just a similar story. We have two things happening in the server. The first one is basically serving different files depending on which endpoint you've hit. The second part is the game logic. Now, it is possible that you use a different physics engine on the server side, because Phaser doesn't really work super well, just the engine part of it on the server. I'm using something called P2. The reason I'm using that is because I'm randomly assigning a new velocity to the ship every 5 seconds. And in order to compute the velocity, I need a physics engine. So that's what I've done. And as you can see, basically it's subscribing to enter, subscribing to leave, and all of the same things that you'd expect from the client side. After 2 minutes, it is publishing the timeout message on the game over event. And the main thing to note here is the game room, where it is publishing the game tick. Okay. Yeah, so this is the game state. I have a start game ticker, which runs every 100 milliseconds. Within that, I'm publishing an event called game state, publishing all of the players according to the local context of the server, the count of the players, the position of the ship, and bullet or no. This is basically to say, every couple of seconds or every half second or so, send a bullet. And on the client side, I'm checking if it's empty, don't shoot a bullet. If it's not, then shoot a bullet with that ID and with that, details, etc. That's pretty much it. And I'm not going to go into the details, but all of this, is available on GitHub. This is continuously improving. There are lots of things. As I was mentioning, there are sounds to be added. There are, I thought of adding, a balloon every 5 bullets or so, which you would actually need to collide with to get extra points. Maybe we start the game for everyone together by waiting for 10 players to join, which was not really practical to do in a conference mode. But hey, there's a bunch of different things in my to-do list. Feel free to, use this to build your own game or contribute, add more features. But that's about for the talk. Hope you liked it.
Sorry. I really just wanted to be on top or something, I guess. I don't know. Anyway, sorry. We are live. Can you see me? All right, we are live.
Can I, can I unshare my screen now?
Yes, of course, yeah.
Okay.
Thank you so much for that talk, Srushtika. That was so good. Your slides are so beautiful as well. How long did that take you?
I spent embarrassingly high amount of time doing that.
It's worth it, though. It was amazing.
Loved it so much. And you said you built that in 2 weeks?
Yeah, actually. And that's kind of why when I was submitting the talk, I didn't really give that title, because I was like, yeah, I'm going to just say some theoretical stuff because I'm not actually sure. I don't want to take a chance. But yeah, it's actually super easy. So
was this conference-driven development? Why did you decide to build a game in 2 weeks?
Couple of things. It was majorly conference-driven development because, Dylan wants everything to be cool. So you got to live up to that.
Jo is a victim of my conference-driven development in her Christmas jumper, so she knows.
So that's one reason. But I basically thought, I have a VR demo that I used in a different conference, and I thought, okay, I have no other new work to do. I'll just use that because it looks cool and everything. But then I started, developing that. But because of the lockdown, I'm not in my apartment currently. I'm with a bunch of friends, so I don't have the VR headset or a lot of different things that I needed to actually put that out. So I was like, right, so what next? Which is cool, similar to VR, that Dylan would like, and goes with the theme of the conference. So went with gaming also because my new boss is really into gaming. And yeah, I thought if things go south, I'll just take his help.
So. Always please the boss.
Nice. I will say I love that most speakers, when they reach out and they propose a talk that has potential for HalfStack, and I kind of nudge them in a direction, take that in stride, rather than saying, yeah, no, I'm going to do this. You were like, oh, that would be great. And then sometimes it just results in brilliant stuff like this. So thanks for humoring me.
It was a really, really enjoyable talk. So I'm not really a gamer, and I'm definitely not somebody who programs games. But is there some resources that you would recommend, either in terms of tutorials for Phaser 3 specifically, or somewhere where we can get assets from if I'm not a designer?
There's actually a person called DJ Skylab on YouTube. I don't know if that's his, I mean, that's definitely not his real name, but he has the best, video tutorial series on Phaser 3. I mean, it's just the background sound and the assets that he creates is super cool. And with every video, he has links to, his website where you can basically go donate as much as you like and get those assets, which are super cool. And all of the things, the way he teaches them is, what's happening behind the hood as well. So not actually implementing stuff that's working, but also understanding what's happening behind the hood. So you have the best approach to things.
That's important to have in tutorials. Some quite often they just focus on the implementation and they end up being copy and paste games.
Exactly. Yeah. Do this, write this statement, and your avatar will be created. I was like, yeah, okay, but you need to know why, what's happening.
So you built this demo for the web, and I had a go of it in my browser with my keys, but is it mobile friendly? Could it potentially run on other platforms?
It would be definitely mobile friendly when run on a browser. The only reason I mentioned use a computer browser is because I didn't have enough time to implement the input from the mobile. But even with other sorts of platforms, if you want to use an MQTT based game controller or something. The particular thing about this game is that it uses Ably, which in turn supports a bunch of different protocols and a bunch of different, SDKs, which means any of the SDKs on one side you can use to communicate with any of the SDKs on the other side. So even if you're using Phaser, which is web only, you can only show it in a JavaScript page, you can still have the users play on different platforms. So it's completely decoupled that way.
That's cool. So when you were building this, I imagine the Ably stuff was super easy and to implement and anybody could pick that up. But was there anything that you challenged you when you were building this? What did you learn from it, really?
I think with all the things I've built with Ably, nothing has been so resource intensive as this one, because it's multiplayer and it is very easy to slip into an n squared sort of situation where, so many messages are being sent and we're basically losing resources, and there's, stuff, basically high peak rates going up and down. But I think the key thing that I learned building this demo is how to most efficiently use these resources in a way of designing good architecture. How you can basically, I built it in 3 different ways, to be honest, and all of those things were from one version to the other. It was a reduction of the number of messages, the rate at which the messages were being sent, but still having the same output in the game. So that's definitely something I've learned.
Cool.
And are you going to do a write-up of this? Is there somewhere we can see these resources if we want to build this game ourselves?
It's on my GitHub that I shared the link, but I will tweet out all of the stuff, including the slides, right after this session. And yes, I definitely plan to do a write-up because it's super cool and I have lots of stuff to share. I will tweet that out as well. So, yeah, I think it'll pop up somewhere.
And is there
a bunch of people making video games and things like that over the coming weeks? Brilliant. Thank you for that.
Is there anything that you want to add on to the game next? Like what's coming in the future?
Oh, bunch of things. I think my to-do list goes more than half of the actual script, number of lines in the script that I have, because I'm like, oh, I could do this. Then I was like, right, there's a conference coming. I need to stop at some point and make my slides because, I need to show the game in a working state and not continuously go and adding things. But, as I was saying, things like starting the game for everyone at the same time, so no one has an advantage of coming to the bottom quicker than other people. Things like shooting something other than a bullet every couple of seconds or so. So instead of avoiding that, you're actually going towards it to get extra bonus points. Maybe something that my boss told me was that it's really important to reduce initial friction for the user. Now, as you see, as soon as the avatar lands, it is possible that the avatar gets killed as soon as they enter because they're not immortal. But it would be good if they are immortal for a couple of seconds after they've entered the game, so they have time to adjust, see what's happening, and also show this in terms of like an animation or something. Also, obviously, a definite thing that I'm going to implement is animation of the avatars matching the classic. I don't know why it didn't do that.
But given this is conference-driven development, you've already mentioned you had a VR project, you've now done a games project. What's going to be the next step? Are the two of you going to combine your skills and we're going to have a jumper filled with Space Invaders?
Oh, you could play Space Invaders on a jumper.
Yeah?
Let's do that.
With your mind. With your mind.
I don't know.
Now all three of us can combine our talks.
Awesome. There you
I'm
go.
slightly concerned about putting wearables on my chest where people are going to have to stare at them to play a game.
Put them on your back and just turn around.
Yeah. But then, all the commands to kill your character would be really weirdly directed at you, so that would just be strange. Oh, it's funny.
Well, I'll look forward to that for the August HalfStack conference.
Yes, definitely. So we still have a few minutes left. So how have you been managing your sanity during COVID besides building a game in 2 weeks? Like, what have you done? Like, I'm asking almost everyone this just because it's like nice to share ideas and it's cool to hear what everyone's doing.
I don't know if I am maintaining my sanity.
I mean, game in 2 weeks. That's not saying.
Yeah.
Jokes apart, I generally am a very talkative person, as you can probably tell. So I generally love going to the office. I'm not like a work from home person. So I'm like talking to everyone, just like if I need something, just what happened to this, etc. So that's been a bit of a bummer to not be able to talk to people. But also, it's getting better by the day. Initially, there used to be calls all the time because everyone wants to talk on calls, and all the communication basically happens on calls. So the day goes in meetings. But now I think things are streamlined. Everyone's understanding how to better manage things. So it's getting better by the day.
Definitely. I have this weird experience that when I moved from London to Phoenix, my commute doubled from 15 paces to 30 paces. So I've been working from home for a long time. But usually what I was used to doing is actually being able to leave the house to do interesting things. And now it's like, well, I just can do more work, or I can hang out with the kids more. And the kids are like, well, what do I do? I don't want to watch YouTube all day. Well, maybe they do, but it's just kind of this, there's nothing to go do.
Yeah.
And there's a little bit, but there's not a lot. And it's challenging. And it's almost like because they can't go, now they want to go more. Whereas before, when they could leave anytime they wanted, they just wanted to sit on their devices, So it's kind of a interesting conundrum. Yeah.
Yep.
So, what about you, Joe and Tony? How have you been coping through all this? I don't want to redo the schedule on the app because it's a pain. So,
for those of you who are watching who don't know, I work with Srushtika. So yes, I entirely feel the pain of the constant video calls. What did Ben say the other day? It's all Zoom and gloom these days.
oh.
That's his favorite, favorite dialogue of the week.
Yeah, I definitely that one resonated with me. But we're fairly lucky in that we can still go out, we can still go for walks, we can still see the sun. And in London, I don't know if you can see out my window right now, but it's glorious sunshine, and it has been for the last few days. So
Nice.
at least we have that to be thankful for.
I don't know if you noticed, but the weather started getting so much better after the lockdown started. It was so bad before.
Conspiracy.
Yeah, because it's like you can see it, but you can't do anything with it.
Yeah, exactly.
And right now, as they're starting to release the lockdown here in Arizona, which they probably shouldn't be doing, but that's another point. Now it's getting so hot you don't want to be outside. So now you actually want to be inside, and we missed the whole nice spring season. So, Anyway, I think that's good. So thanks so much for your amazing session, and there's lots of nice comments. So thank you. We'll do some real applause here. Yeah.
Thank you very much for having me.
Thank you.